Today we're going to discuss the definition of similar figures and how to solve for a missing side length, as well as how to determine scale factor. Okay, so two figures are similar if there is a corresponding congruent angle in both figures. So what does that mean? That means is if angle A is 110 degrees, that means that in my smaller quadrilateral, there must also be an angle that is also 110 degrees. That makes angle A and angle W corresponding congruent angles. Each angle is obviously congruent to one another. Okay. And because a quadrilateral has four angles, that means all four angles have to match in the other quadrilateral. So for example, angle D, let's say, is 65 degrees. Then that means angle Z must also be 65 degrees. Okay? For every angle measure in one figure, there has to be the same measure in the other figure. And as long as there are four angles that match in our larger quadrilateral to our smaller, then we know we have similar figures. The other way to determine whether two figures are similar is if all four sides have the same scale factor. Okay, so scale factor is comparing how much bigger one quadrilateral is to the other. And we do that by matching up the sides. Now, we can do that. As you noticed, initially there are no angles here that tell me which angle is congruent to which. But what I do have is this thing right here that's called a similarity statement. Okay. And this similarity statement tells me, and this little symbol right here in the center, that is what it means to be, that means similar. Okay. And the similarity statement tells me which angles are congruent to which. And I said initially that A and W were congruent because they're both listed first. Okay, so A must be congruent to W if my little symbol here tells me that the two figures are similar. I also said that D and Z were congruent. Again, we have the similarity symbol, and both D and Z are listed last. So those two angles are congruent. So the order of the letters tells me which angles are congruent to which. Okay, so if you notice, angle B is the second letter listed, and in my other figure, X is the second letter listed. So angle B and angle X are congruent. Okay, now using those angles, I'm going to use X and B. I'm going to use a single arc there. I'm going to use the double arc for Y and C because those are both listed third. I can now match up which sides are congruent, or they're not congruent, which sides are proportional or have the same ratio. And in this image, the sides are color coordinated for you. But on a black and white piece of paper, you'll notice you see how BC here is between the single arc and the double arc angle? Well, XY is also between the single arc and double arc angle. So BC as written down here, BC corresponds to XY. So the length of BC is 12. The length of XY is 4. That is our scale factor. Okay. To determine scale factor, we compare the side lengths, just like I did here. Now, writing it as a ratio, I can write it like 2:4, but you're going to see it most often as a fraction. Now, AB, our orange line, AB goes to WX, which I can also pull from my similarity statement because they're the first two letters. So those sides must match as they indicate here. Now AB is 15 and WX is 5. Okay. Now with a similar figure, the ratio between all the side lengths will be the same. So how are these the same? 15 over 5 and 12 over 4. Well, if I reduce them, I will get 3 over 1 for both. Here I can divide both top and bottom by 5 to get 3 over 1. And I can divide both 12 and 4 by 4 to get, because 12 divided by 4 is 3 over 1. So in each case, I do get the same scale factor when I reduce the side lengths. Okay, so the first part of solving or understanding similar figures is coordinating and matching up the correct congruent angles, which therefore allows me to determine which sides are proportional or corresponding. And then I can get the scale factor by writing the length. It's just the lengths. The scale factor is just the lengths of the sides. Okay, the lengths of the sides, the comparison of the length and the size, either as a fraction or as a ratio, tell me what the scale factor is. Okay. So here you can see this is a representation of corresponding congruent angles. Okay, because you see here A has a single arc, W has a single arc, D has 4 arcs, Z has 4 arcs. So those tell me those are congruent. The number of arcs at the angle tells me which matches and which corresponds congruently. Okay. So let's take a look at page over. Okay, now here we are gonna identify using our similarity statement. So our similarity statement is right here, and you'll see that A is first, A goes to P, B is second, Q is second. So B and Q are congruent. So starting with A, I can use a single arc for A, and A is congruent to P. B is second, and that is congruent to Q. C is third, and so is R. So C is congruent to R. And then D is congruent to S. Those are both listed last. And I'll use 4 little arcs there. Okay. So now that I've labeled my corresponding congruent angles, I can now set up and match up which sides are proportional, okay? And that's going to help us in solving for missing side lengths, okay? So you notice how AB, okay, is between the blue and the red angle. PQ is also between the blue and the red angle. So that means AB is proportional to PQ. Next I have BC. Okay, B is between the red and the green angle. So QR is also between the red and the green angle. So BC corresponds to QR. Next we have CD between the green and the red angle. And that's the same as RS in my other figure. So we can say CD corresponds with RS. And then last but not least, we have AD, which is between the black and the blue, and that's PS, black and blue. Okay. One thing I also want you to recognize is that the side lengths from the same figure match up horizontally, okay? So all the sides from our large kite are on top, and then all the sides from my smaller kite are on the bottom, okay? This is important. You can't intermix them, okay? You have to match them up horizontally. Now, I could have set it up where I put all the sides from PQRS on top and then ABCD on the bottom. That's fine, but you have to be consistent, okay? Your side lengths must match horizontally. Okay, so all the side lengths from PQRS have to be either on top or bottom, and the same goes for ABCD, okay? Now, if you want to fill out the bottom part, you can. It just goes through everything that I had mentioned already, right? So why is this important? Okay, because it's going to allow me to eventually solve for a missing side length, okay? Here it's just, in this particular example, it's just asking us to find the scale factor, okay? So remember, scale factor matches up the sides. So here, so our first, we have NPQ, and I have RST, okay? And I need to find the corresponding sides. So you notice how NQ is between the single arc and the double arc. Well, that is the side that's the single arc and the double arc is RS. Okay, so be careful. They're not, your figures are not always going to match up exactly based on the picture. Okay, they're going to purposely turn things on you. Okay, so NQ corresponds to RS based on the angle measures. Okay, then I have, let's see, QP, that's between the double arc and no arc, so PQ, and the double arc and no arc, that's ST, and of course, last but not least, is going to be NP, and because that's a single arc and no arc, and RT. now that my side lengths are all matched up, I can now fill in the values of those lengths and determine scale factor. Okay, so let's see, blue. NQ is 12.5. Oh my, that is not what I wanted. Okay, 12.5. RS is 10. PQ is 11.5. And ST is 9.2. And NP is 15. And RT is 12. Now in our other example, I just reduced the fractions, and I can do that for 15 over 12. Okay, both 15 and 12 are divisible by 3, which is going to give me 5/4. Okay, but the other two fractions have decimals in them, so it's going to be easier just to divide and find out what the value is numerically. So I'm going to do 12.5 divided by 10. Which gives me 1.25. Okay. And then I'm going to do 11.5 divided by 9.2. And I get 1.25. And when I do 5 divided by 4, I get 1.25. So you'll notice the ratio between all three sides is exactly the same. Okay, that means these two triangles are in fact similar. Okay, now we have another example. Try this one on your own. Okay, try lining up the, or I should say, create the scale factor I did above. Okay, coordinate your, match up your letters. I'll do the first one for you. AB, which is between the single arc and double arc, is comparable to LM, which is also single arc, double arc. And fill in the numbers like I did above. And see if you get the same ratio for all three sides. But what's important is I want to show you how we solve for a missing side length, or in this case, we're going to solve for y. Okay, now there's only two sides here, okay, for each. So it makes sense that the short side RS corresponds to YZ. Okay, and I can confirm that by checking my similarity statement, and sure enough, RS and YZ are the last two letters in my similarity statement, so those two sides are correspondingly proportional. Okay, so then I can say SP is proportional to WZ. Okay, and again, SP is the first and last letter, and WZ is the first and last letter, so I know I set those up correctly. Okay, now next I'm going to fill in the values for those sides. So RS is 6, YZ is 5y minus 2, and that's going to equal SP, which is 12, over WZ, which is 16. Okay. Now, also keep in mind, the letters from the same figure match horizontally. So all of my side lengths from the smaller quadrilateral were on top bigger one over on the bottom. Now, if you intermix them, put the big one on top and the smaller on the bottom, that also works. So that's totally fine. To solve this, we are going to cross multiply. Okay? So when we cross multiply, just like I got down here, okay, we get 6 times 16, which is 96. And then we have 12 times y minus 5. So don't forget, we have to distribute. So we get 60y minus 24. Now, to get 60y by itself, I need to add 24 to both sides, which does give me 120. And then my last step to solve for y is to divide by 60. Okay? So when solving for a missing side length, we need to set up this proportion, match up our corresponding sides, and then to solve, we need to cross multiply. Okay, let's give this one a shot. Okay, so AF is the last two letters. So it's going to be corresponding to the last two letters VZ, and then CD, which is the middle two letters, will match the other middle two, which is WY. Let's fill in our information. VZ is 3y minus 1. CD is 9. WY is 6. Okay, so set up your corresponding sides, fill in the information, the length of each side, and then cross multiply. So we're going to have 9 times 3y minus 1 equals, when you cross multiply, then you get rid of the fraction, setting the two cross products equal to one another. And 12 times 6 is 72. Distribute the 9. So 27y minus 9 equals 72. Add 9 to both sides. So I have 27y equals 81. If I did my mental math correctly. 72 plus 9 is 81. And when I divide by 27, I get y equals